Okay, so the second functionality of the operating system is that it is providing you a user interface. So you interact with the operating system through its user interface. In past, when we had no operating system, so we typically used it with the command line interface that we will discuss later. Okay, so you interact with the operating system through its GUI, which will help you in selecting the menus. It will help you in making your life easier. So there are two types of operating system user interfaces, that is the graphical and command line. The one we use, it is the graphical user interface, that is the GUI. So this user interface controls how you enter data and instructions and how the information is displayed on the screen. So this graphical user interface has made our life so easy. So with the graphical user interface, we can interact with menus and visual images. So the icon of my computer shows that we have drives in it. The icon of recycle bin shows that it has all the items of that we have deleted, and the icon of folder, there are various icons of folders and files, etc. So operating system user interfaces often use a combination of these techniques to define how a user interacts with the computer or mobile device. So GUI is the thing that we usually we usually work with. So it has made our life easier by touching. We can touch to those applications, we can point them, we can tap them, we can double click them to open, we can use the mouse pointer to close them, to open up them, etc. So there are lots of things that have made our life easier. So many current GUI operating systems incorporate features similar to those of a browser. For example, we can move forward, we can move backward. There's a back, if you have noticed, there's a back button on the on your, when you open up a folder, there's a back button, there's a forward button, so you can navigate from one file folder to another folder. You can directly jump to one folder. You can locate files, there's a search bar, you can locate files. So this graphical user interface can come with you can use mouse to interact, you can use a touch interface, or you can use the natural interface. So a graphical user interface designed for touch input sometimes is called a touch user interface. So your mobile phones, your tablets, they are having this touch interface nowadays, or desktops and laptops, they also come with this touch interface. These operating systems for desktops and laptops and may have this touch user interface. And then we have a third type of interface, that is a natural user interface. Okay, with the natural user interface, the user interacts with the software through his ordinary intuitive behavior. That is, it can be a touch screen, it can be a gesture, motion input, speech recognitions. You can use your voice to open up, you can use your voice to shut it down, and the virtual reality simulations can be used as well. Okay, then another type of operating graphical, sorry, the user interface is the command line interface, another type of the operating system. So which is usually used to configure the devices. So in past, when we had no graphical user interface, we used this command line interface. So it is a user type, in it a user types commands which are represented by short keywords or abbreviations, or some special keys to enter the data and instructions. And then you can configure your devices. You can automate the system management tasks, you can troubleshoot network connections. So network administrators and other technical users work with this black screen. That is, they type some instructions, and the softwares will be installed on all the devices. And you will type commands by in short words. The difficulty is that command line interface is difficult to use, because you have to write down the exact spelling. So even if you don't write the exact spellings, then it will not work. Even if you have to add punctuation, so it should be exact. So minor errors, that is missing a full stop, missing a comma, will generate an error message and it will not work. So command line interface, however, gives a user and administrator more control to manage the detailed settings of the system. So whenever you work with this command line interface, the set of commands will help you to control your system very easily. um, Another functionality of operating system, as we discussed earlier, is the management of programs. So how an operating system handles programs directly affects our productivity. So operating system can be a single tasking operating system, it can be a multitasking operating system, it can be it manages programs by working giving you the flexibility of the foreground and background feature, and the single user and multi-user feature as well. So a single tasking operating system, as the name indicates, it will allow only one program or app to run at a time. For example, if you are using a browser and you want to check email, so you must exit the browser before you can check the email program. That is the single tasking operating system, that is you can do only one task at a time. So multitasking operating system is the one where you can do you can use a you can you have opened Word to type, and you are using a browser to find out words, and you are copying it and you are adding it there. So you are multitasking, you have opened multiple tasks at the same time. So operating systems on embedded computers and some mobile devices, they use single tasking operating systems on some mobile devices. So a multitasking operating system will allow you to work on two or more programs, to work on two or more apps. So more apps can reside in memory at the same time. So if you're working with a multitasking operating system, you don't have to exit the browser to open an email program. So you can use both programs at the same time. You don't have to exit one program to use the other program. Okay, then we have multi-user operating system and single user operating system. As the name indicates, a single user operating system is for you to use at your home, whereas a multi-user operating system enables two or more users to run programs simultaneously. So the operating system on the network, servers, and supercomputers, they allow hundreds to thousands of users to connect at the same time. That is, if you are using computers on your labs, you are actually using multi-user operating system because it is being run at the server. Then we have the foreground and background applications. So when computer is running multiple programs concurrently, one program is in the foreground, that is the one you can see, and the others applications, they are in the background. That is, you have opened up those applications as well, but they are in the background. So the one in the foreground is the active program, and the one in that you are currently using, and the other programs, they are also running, but they are not in use and they are in the background. So the foreground program, it typically is displayed on the screen, and the background program are hidden, or you can double click to minimize it. They are completely behind the foreground program. So multitasking operating systems user interface, it allows you to switch between foreground and background programs. You can open up the pictures, you can open the email, you can open the Word file, you can open the Excel sheet. So you can work on foreground and background programs. This flexibility is also being given to you with the help of this foreground and background features of the operating system. That is, operating system manages its applications this way. Okay, so management of memory. So if several programs are running simultaneously, your computer or mobile device may use up its all the available space, all the available RAM. So memory management optimizes the use of computer or device's internal memory. That is, if you have opened lots of programs, so you know that all the programs are being loaded to the RAM. So if you are running lots of programs, so all the memory will be used. So operating system optimizes the usage of that internal memory. So if you interact with the program, a part of it maybe in the physical RAM, while the rest of program is on the hard drive as the virtual memory. So that is, operating system has this ability to maintain a virtual memory on the hard drive, which is actually a portion of storage medium functioning as additional RAM on the hard drive. So because virtual memory is on hard drive, so it is slower than RAM. So but may or may not notice that the computer is slowing down while it is using its virtual memory. The area of the hard drive used for virtual memory is called a swap file. So okay, look, if you look at this diagram, you see there are lots of programs open up on this RAM. So if it is running out of space, so what it will do, if you open up a new program, it will swap one program from the program that you are not currently using. It will swap it into it will move it to the hard drive. That is, it is known as the swap file. So because it exchanges the data or information and instructions from memory to storage. So a page is the amount this page is the amount of data and program instructions that can be swapped at a given time. So this technique of swapping, okay, so when you need it back, it will be swapped back to the RAM. So this technique of swapping the items between memory and storing is known as paging. So this paging is from memory to RAM, so from memory to hard drive and hard drive to memory, or from RAM to hard drive. It is a time consuming process for the computer. So when an operating system spends much of its time paging instead of executing the application software, it is known as thrashing. So with virtual memory, operating system allocates a portion of storage medium such as a hard drive or a USB flash drive, and it works as an additional RAM. So a part of hard drive becomes an additional RAM for it for the time being. Another functionality of operating system is the coordination of tasks. So operating system determines the order in which the tasks are processed. So that is, which task will be executed first and which task will be executed later on. So a task or job is an operation that the processor has to manage. So the tasks include receiving data from an input device, then it will do the processing on it, and then it will send the information to output device that the work has been done, and then it will transfer the items from storage to memory, and from memory to storage. So this is actually the coordination of tasks. So sometimes a device already may be busy processing one task when it receives another task, especially in the multitasking operating systems. For example, if your printer is printing a document, and when the operating system sends a request to print another document, then the printer must store the second document in the memory until the first document is completed printing. So when it is waiting for the devices to become idle, the operating system places those printing documents in the buffer. So if you have used a printer at your home, you might have noticed if you send 2-3 commands to get its print, the only one is being printed, the other remain in the buffer. So buffer is a segment of memory or storage in which items are placed while they are waiting to be transferred from the input device or to an output device. So operating system has this functionality to use the buffer to coordinate tasks, which tasks to execute first and which to buffer. So this sending of documents to be printed to a buffer instead of sending them immediately to the printer is known as spooling. So if a printer does not have its own internal memory, or if its memory is full, then the operating system's buffer will hold the documents so that they can be waited to print while the printer prints from the buffer at its own speed. So by spooling documents to a buffer, the computer's processor can continue interpreting and executing instructions. So it do not wait for any other things. It continues its works. So this allows user to perform other activities while the computer is printing. So you can open up any other document to do work on it. Your operating system is on the back side, it is managing the documents in the buffer to print them. So you know, they are you see, there is this is a queue. Multiple documents are lined up in that queue, in the buffer. So the program spooler will intercept which documents to be printed first, and which to be placed in the queue to be printed later. And you, while throughout this process, you can continue your work. Another functionality of operating system is the configuration of devices. So every device connected to a computer, such as any device, it can be a monitor, it can be printer, it can be a digital cam, portable media player, USB, or if you plug in a smartphone, so they have a specialized set of commands, and it requires its own driver. So have you noticed, when you plug in a USB, you see there's a message that pops up, so that it is actually configuring that device. So when you start a computer, or connect a device, you connect a printer, you connect anything via USB port, the operating system will load the that device's driver. So the driver must be installed for each connected device in order for the device to function properly. So driver is actually a small program that tells the operating system how to communicate with a specific device. Um, so you know, for every device, the drivers must be installed so that it can work properly, because the driver will tell how to communicate with your printer. The driver of your scanner will tell how to interact with the printer scanner, sorry. So if you attach a new device, for example, any portable media player or a smartphone to a computer, its driver must be installed before you can use the device. Usually it happened in the past, but today what happens, most devices and operating system, they support plug and play. That is, the plug and play will automatically configure new devices as you connect them or as you install them. So you don't have to install the specific drivers for them, it will automatically start working. So it will assist you in the device installation by loading the necessary drivers automatically from the device, and it will check for the conflicts with other devices. So you will plug a device, and it will start working immediately without having to configure it manually. You don't have to configure it, you don't have to enter any instructions to configure it. It will automatically configure the devices with this plug and play technology. Then monitoring of performance is another operating system function. Operating system typically includes this performance monitor, which is a program that will assess and report the information about various computer resources and devices that are open. So whatever programs you open up, and there will be a record maintained by the performance monitor, which will check which program is taking how much memory, and which program is using how much space. So users can monitor the processor, drives, network, memory usage, all these things. So these are the stats you can see: CPU, memory, network. So the information is, this performance report will help you to identify if your computer gets slows down, so you can easily resolve any issue. For example, if your computer is running extremely slow, so the performance monitor, using this performance monitor, you can determine that the memory is being used by which program. So you can close that program, or even if it is again not working, so you might consider installing additional memory in the computer, and then your computer will again start working. Or you might consider restarting your system, so it will start working again.